Free to go.
Carl, I'll just do a quick introduction if you don't mind.
Sure, go ahead.
Okay, so welcome Broward County Schools students, participants of the ACE Mentor program for another exciting evening of a guest speaker and a virtual meeting as part of our 2022-2023 ACE Mentor program. Tonight's class, in accordance with our curriculum and our schedule for the year, is about building information modeling, known as BIM in the industry. And I say any further, I am going to turn it over. It's to Car Ho. Car is a long-serving mentor within the ACE Mentor program in Broward County, part of the executive board, and someone who is an expert in building information modeling. So Car, at this time, I'll let you start.
Well, good evening, everyone who is on the line. So I guess it's 3 students, but for all of you who will be watching this, hello. My name is Car. I'm with Current Builders. I've been with Current Builders for, I'm going to say my whole career, because I'm not going to count on my internships because they were with architecture firms. But anyways, I graduated from the University of Florida bachelor's was in 2005. Then I got my 2 masters in architecture and building construction. And then after that, I came to work for Current Builders, where I am the BIM/VDC director. So there we go. So what is BIM? BIM stands for Building Information Modeling. And it's a digital representation of the building that, or the project that we're about to build. And the point of BIM is for information management. If anything, think about this, like most of the time it's represented in a 3D model. But really, if we were to kind of take a step back, all it is just a visual database. We're taking all this information that the project team is getting, such as like window sizes, door sizes, model numbers of, washer dryers, and I'm taking all that and inputting it into this model. You might be like, Carl, what does a refrigerator model have model number have anything to do with building and building? Well, I take that model number and I actually go look up the equipment itself, find out the exact sizes, any required clearances and such, and we model it into the building and see if it actually fits with where it was designated or if there's any problems. So that's really BIM in a nutshell. And then the other term you'll hear that's pretty synonymous with BIM is virtual design and construction, VDC. If you're to kind of think about it, like what's the difference of it between BIM and VDC? VDC, it's really the process of BIM, at least how I view it. It's, BIM is really more of a specific item. In this case, it's a model, whereas VDC is, taking that model and extracting information out of it. How do you work with that model? What else? What other information can you extract or visualize with it? It really refers to the life cycle of it. So think of it as dimensions. You have 2D, 3D, which is X, Y, and then a Z is your 3D. And then the 4D is estimating, where you start to add cost to it. And 5D is really time. Sometimes, depending on who you talk to, they'll interchange that. 4D is time while 5D is cost. So, to me, it doesn't really matter because it's going to get captured one way or another. But, from that, in terms of time, we can make an animation of how our project is built via the model. Assign like, hey, in month 1, we have the columns and foundations going up, and then you'll see, now that I think about it, I probably should have pulled up one of my old timeline videos, but, we could digitally see how this building is supposed to be constructed, which is a very powerful tool. We all hear of, pictures worth 1,000 words. Well, in this case, a video is worth a whole building per se, in which case, it could really help people understand, hey, how does this thing go up? And as it goes up, like as it's being built, what are the cost implications looking like? The advantages of BIM, It allows for design flexibility. Most of the time, I'm not going to say that the whole BIM VDC process is a new thing. I don't even think it's a new word because it's been in existence for about probably about a good 14, 15 years. Interesting note, the software I used for BIM, Revit, I believe that used to be a Boeing software. And for those of you who know the name Boeing, they're an airplane manufacturer, and they use that first in one shape or form, that software, to catalog their parts so that, as they're building this complex plane, they write down model numbers and of all these parts that they're putting a date as to, hey, this is when it was installed, so that people can always go back to this model, click on certain parts and see, hey, does this need servicing? How long has it been in the air for? When was it installed? Is there still warranty? So that's people in the construction industry then started thinking, hey, why not take this and apply it to a building? Because the building is essentially kind of just as complex. You have a lot of parts and pieces in there, and at least from an ownership standpoint, they would like to know. Well, one of their biggest problems also is usually keeping track of, hey, how long is the warranty on air conditioning units or my stoves or refrigerators and all that. So BIM can help solve that. So how does that help with design flexibility? Well, believe it or not, I would say probably still more than half of the industry doesn't really fully use. Actually, I shouldn't say it like that. A lot of professionals in the industry, I would say probably more than half, haven't really switched over yet, just because of certain work styles or workflows. They're still designing in CAD file, and they could just do it fast. And then now we're saying, hey, here's a modeling software. And I know a lot of you students out there are learning was it SolidWorks? By learning SolidWorks that there's a whole process learning a new software. So that's usually a little bit of a barrier to point of entry when it comes to modeling. But what happens is, so we get these plans that come from an architect and engineers also referred to as a design team. And it's all in 2D, and they're like, hey, this is a design that's set, great, let's rock and roll, let's go on to build. But then with BIM, I could actually go ahead and convert that 2D information, your plans, into a 3D model per the specs to see, hey, is there information missing, or are there problems with the design, such as like, hey, in a bathroom, you put in this cabinet and a toilet and a tub. Next thing you know, you only have like a very small space to move about, or it doesn't meet building code. This model allows us to forecast those items and help with the design flexibility of it, and letting the project team know, hey, you have an issue here before we even build it. Because as we all know, and this goes into the next point, time is money. And if we have to go back to do rework, meaning, we already spent, let's say $500 to build this bathroom. Oh, now we have to go back and fix it, meaning we have to tear it down, which we have to pay somebody, and we have to come back and redo the work, which is, let's say 2 to 3 times the cost of what it originally was to build it. So by kind of forecasting these things before we build it, we can actually help reduce cost of a project. And then also, kind of parlaying into the schedule improvement, like I said, time is money. We saved also time by having to prevent, the trades, the AC person, the tile guy, the cabinet guy, from having to go back into the unit to redo the work. So, let's say we projected it takes about a month to build a bathroom. Then we have an oopsies, some stuff doesn't fit or doesn't meet code. Next thing you know, we have to spend extra money and extra time going through to rebuild that bathroom. And then, that starts to delay other things down the line. So, that's the advantages of BIM. It helps us with design flexibility and resolve problems before we even build it. And because of that, it reduces cost, and it helps us actually improve the schedule sometimes. Not only does it help to either maintain the schedule, but depending on what information you take out of it and give to the trades to use, sometimes it could actually help them go faster in building things. Licenses and certifications, are they required for BIM? No, they aren't. It's not like, you know, an architect where they need to, I mean, really somebody can be practicing, but is it legal for them to? No, it isn't. Like they can't sign and seal a drawing because they're not a licensed professional. Or like an engineer to where, you know, they need to, you know, go through a certain amount of mentoring and then take a test. And the next thing you know, they can sign a stamp and approve certain designs. With BIM and VDC, I mean, there are certifications out there, but it's more in terms of usually software. Sometimes it goes with, hey, we're just certifying that this person knows this kind of process about how to do things, but it's not required in order to work with this kind of technology or this process in the construction or actually in the building industry, really. I mean, it always helps to be licensed or certified, but it's not a requirement for you to go in there, especially because most of the time, at least with what I've been doing for these past 13 years, I'm not certifying any designs. I'm only checking designs. So, you know, that doesn't really need a license or a certification of any sorts to do what I do. But really, um, one key thing though, you know, you got to enjoy what you do. And with BIM, you know, it's very technology focused. You know, you have to have an interest in technology. You need to have an interest to be able to go in and tinker around with the software or, you know, some of the tools that we use and see how they interact. And, you know, if you have an interest in technology, you can go a long way. I mean, just to let you know, I started out in high school, Coral Springs High School, with a drafting program just because I had an interest in computers and I like drawing in AutoCAD. And, you know, because of that, you know, I didn't really care about a building, but I thought it was cool. Hey, I could draw this to like exact specifications and somebody's going to go out and build it. That really interested me. The fact that, you know, instead of hand drawing it, you know, I could use computers and all that to build a building. And that's what kind of got me interested in going into architecture and building construction. And then while I was in building construction, that's where I learned about 3D, or well, this kind of 3D modeling, and how it could actually impact the industry and, you know, help save time, well, time and money. Um, so, you know, it's best to have an interest in technology or just, you know, any interest in this whole process, which I will show you later on, the different facets of it. Now in BIM, you're going to see that there's what's called LODs, level of details. Here's kind of a very simple graphic that shows you the different levels. Starting from the right hand side, you can see like, hey, I think that's a rabbit, but it's kind of some type of shape there. And then as you can see the progression that gets more detailed. So there's 5 levels of details. The least amount, which if we were to compare to the graphic up there, the level 100 is the least detailed. And then the most detailed is level 500, which you see on the I'm sorry, on the left-hand side. But to kind of give you a summary of each level of detail, level 100, let's just say if we were the example of a keyboard, all right? So picture, if you will. Level 100, you just see a rectangle, okay? And it might have a label of keyboard. So you know it's an object and you know it exists, okay? That's level 100. Level 200 is, oh, it's a Logitech keyboard. And you might see that, you know, it might be a color black or something. You know, or it could be, you know, a white keyboard with yellow keys. Okay, so that's the extent of it. Like you don't know how many keys are there, but you know, like, hey, there's some type of differentiation there. Then you have a little level 300 where it gets a little bit more detailed now. Okay, this picture starts to become a little bit more clear. Like you see the outline, the overall dimensions of this keyboard. You see that, hey, there's approximately, you know, at least 50 something keys on this keyboard. You don't know the size of them, but you know, like there's a count. There's a model number attached to it. That's level 300. Level 400 is, okay, now I see the exact dimensions of the keyboard. I know the exact dimensions of every little key and where they're placed. You know the specific model number, you know what options are available, and you know the color combinations that you can have for the keyboard body and the keys itself. And level 500, which is the most detailed, is you built this keyboard and you go back to measure every single little portion to see, hey, like, is it, it's called an as-built, is what is on the sheet and what's been built, do they exactly match up? And if not, then what were the actual dimensions after you built it? Okay, what are those dimensions? And then you're going to update the specification sheet, or like, that drawing of the keyboard to match exactly what was built in reality. So those are your 5 level of details. That's important to know in BIM because if you guys ever get into a modeling career, you kind of, the cost of doing BIM depends on your level of detail. Obviously, with the least amount of details, it doesn't require that much work to get into and produce, but you're also not getting that much information out of it, so it's not going to cost as much. But then when you go into more details, it's more work you have to put into it, making sure that things are accurate and right, and per specifications, and this and that. So it gets more expensive. So that's why the level of detail plays a very important part in BIM. Now we kind of got that out of the way. Now, to me, one of the first stepping stones of BIM is really in the office environment and with software. All right. There's several big names out there in the software industry when it comes to building information modeling and virtual design and construction. Autodesk, it's a huge monster. They have a bunch of software in there, starting with AutoCAD, but then, in terms of items specific to modeling, you have Revit. That's a model authoring software. Then you have Navisworks. That's the software that takes the model and actually analyzes it to see what objects actually clash with each other. And then you have Procore, that's more of a information hub, or kind of like a project management software. A lot of the software that we're using to do the models can now feed into Procore, which is great because a lot of these softwares like Revit and Navisworks, a lot of people in the construction industry, aren't very privy to it. So it's not like I could just give Jacob or Matt my Revit model and say, hey guys, go figure out the building, because then they're going to look at me like, Carl, you're crazy. But then, sometimes I could extract information and bring it into Procore. Now, there's other types of project management software. This is the one that Current Builders uses, so that's why I'm just talking about it. Then you have SketchUp. That's another model authoring software. I don't know about you guys, but this is one that I introduced to the kids at Coral Glades, because Revit, while yes, that is a modeling software, it takes months, if not years, to learn it. And with the kind of timelines we have for ACE, there's just not enough time. But SketchUp is it's a very simplistic program which can get very powerful, and you get very detailed with it. And then Trimble, they're a big company just like Autodesk, but they have not only software, but they have hardware as well that support modeling, the modeling process, which I will show you kind of one item that we mainly use their hardware in the field, but they do have some model authoring software as well. And then you have ArchiCAD. I just threw that in there just because I don't use it, but it's another modeling software. I think in the past it used to go toe to toe with Revit, but then I think since then they've kind of quieted down a little bit. Before I go into the hardware, I'll show you some of the software portions of it. So starting with Revit. Oh no, my touchpad kinda doesn't really, okay. I will make do with what I have, if I could figure it out. Not. Give me a moment, guys. I apologize for this. I knew there's a reason why I plugged in this now. Okay, here we go. So this is a model authoring software. This is a building that we are actually currently working on. I just cut 3D slices out of it, but you can see as I zoom in, there's actually a certain level of detail where this might not be the exact fridge that we're using, but it's going to be the exact size, especially because a lot of objects in this model are at a LOD 300, which we're just more concerned with the overall dimensions. And then from that, we could check, anything to do with building codes or clearances. But, we can get pretty specific with this. But for what at least my company needs, this is the level that we get to. So then once we produce this model, then we can actually bring it into the next piece of software, which is Navisworks. This is what actually goes through and looks for clashes. It will take all the information from Revit, and it'll go through and analyze, hey, do things overlap? If it does overlap, then we know we have a problem. Like, what's this one? Floor, pipe, run on floor. Okay, so this one was really more of a modeling error. Actually, it looks like it might have been a pipe from somewhere else, but this probably happened because the fire sprinkler trade told us, hey, install it at this elevation, and that's what they have in the model. When we did it, hey, this is where it ended up. So it was obviously a mistake, which they can't have because their guys in the field are relying on this model to build by. So you see, hey, obviously we're not going to have that pipe. Have that pipe in the floor. So this is one that one of my associates goes back to the trade to tell them, hey, here's something that's wrong. But we go in and model every single component that we want to see, hey, does it fit in the ceiling? More times than not. Actually, what is this one? Oh, for those of you in Broward County, more specifically in the Margate, Coral Springs, Tamarack area, this project that we're looking at, it's a project on the Coral Square Mall lot, right behind the movie theaters there. This is Metropolitan Coral Springs. This is the apartment buildings that you guys see going up. More often than not, a lot of the times when the engineer goes and designs their air conditioning systems and the plumbing systems, the architect doesn't like to give them a lot of room in the ceilings. And that's just because, the architect is thinking about the tenant wanting to be in a bigger space, so they don't want to lower ceilings. And that's where I come in and say, hey, your system does or does not work in this space. So what can we do to rearrange some of these ducts or pipes? And if we can't, then sorry, Mr. Architect, I need to lower the ceiling because this stuff doesn't fit in there. And more often than not, it's this kind of stuff, which seems pretty easy to figure out, but it's not. And that's what causes delays because, when the trades go in there to install this, they're like, hey, we installed it. And the framer goes to put up the ceiling. He's like, hey, I can't put it in at the elevation that you want me to, or at the height that you want me to. So, and think, I'm just looking at one unit. Imagine zooming out and, what if it happens to every unit on every floor? And you know what? I don't remember how many units are in this particular building, but let's just say, what happens if that happens 300-400 times? That's a lot. So that's really the software that we use as part of our BIM process. That's what happens inside. And this one's kind of embarrassing. This is cool. I think it's a little bit more relatable to you guys, but I call this a Unity model. It runs off of the Unity engine. And if my mouse actually worked how it was supposed to, I could actually, as I move my mouse around, it's like your head's turning and I could look every which way, but it doesn't. But what's cool about this is it's an interactive model. Using my ASDW keys, I can move forward and backwards. It just stinks that my mouse can't scroll around to look. But what's cool about this model that we use for our clients is material sample selections. I went through, scanned all their materials and applied it to the model. So they can actually walk into their model, into their unit and see, hey, what looks good? This backsplash isn't changeable, but they can go through, choose different color combinations, see, hey, do I like this countertop better with this cabinet color? Or should I go with a mocha color or this really light plywood color? But anyways, and they could actually see, hey, these light fixtures, do I like the way these light fixtures look? Because we actually modeled it per what they had selected. So this helps fast track their decision-making process, especially nowadays. Why that's important. And, Jacob and Matt could really attest to this, but, because of the pandemic, you hear of a lot of long lead times, meaning when you order something, it's not like Amazon where you just get it right away. You have to wait for them to build it. acquire the material to build it and then ship it out. So there's a lead time to that, and a lot of products are now at a point to where it just takes a long time for them to come in. So what happens is, what this model allows the ownership to do is compare it in context, because previous to a model, they would just get like these small little paper samples sometimes, or maybe a small piece of the countertop, and they have to try to imagine a whole room and pick out colors and patterns and everything to go together. And this allows them to make that decision much faster. And then from that, we could order things much faster, and then get in line to get the materials. And why that's important is, again, because of the long lead times, it helps us make decisions faster, so we could get these products faster. Matt, I see that. I don't want to kind of switch out of my screen, but I see
Sakshi made a comment. Uploading the model into Unity also allows us to use VR technology and potentially AR, where you can add and change layout in real time.
Yep, that is true. I'll let you know, kids, the reason why I don't use VR yet, I haven't found a way to not make the clients seasick. I don't know about you guys, but every now and again when I jump into Call of Duty after not playing for a while, and I go through and play the game, I actually get motion sickness, and that's actually a genuine concern we have to take into account, because there was one time we actually got a VR headset, applied this Unity model in there, and as soon as the owner started going through, he wasn't too great at maneuvering. He actually got a little motion sickness. So then after that, we're like, hey, we're gonna cool it with that. But as soon as the technology gets to a point to where, hopefully I can immerse them in there without getting seasick, you can bet you that we're gonna be using what Soxy was talking about, which is the VR portion of it. Was there another comment in that came up, Matt?
I just
No,
followed it up with good point. We need better hardware.
Yep.
Yeah, I believe AR would be better, augmented reality, because that way you can get your bearings of the surroundings and actually see it laid out in the space.
Well, before you guys blow up my spot, let me get into hardware portion of
Okay,
it.
let's stop.
So you guys just saw the software side of BIM. Okay, this stuff primarily takes place in the office, and we go through our coordination. My team reaches out to the architect, reach out to engineers, and we get all this stuff nice and pretty. It all fits, and now we go build. Now the big thing is, okay, how do we get what's on our computer out into the field? Because I could tell you, a lot of the laborers, foremen, superintendents too, sometimes, if I try to give them a computer, and it'd kind of be equivalent to me giving this model to Jacob and Matt. Sorry to pick on you guys. If I give it to them, they're going to be like, Carl, what do you want me to do with this? I don't know what to do with this. It's going to be the same thing with the guys in the field. So and this is what I kind of find as a fun part of my job, is the toys, the hardware. And here's one such hardware that current builders use right now. It's a Robotic Total station. This is very similar to those units that you see. I don't know if you guys, if you ever take trips or just drive around town, sometimes you'll see these surveyors that are holding a prism pole, and there's what's effectively called a gun, or the total station, which another person is looking through to gain measurements. That's them going out there, laying out specific points on the landscape, trying to get dimensions and map out the landscape. Well, we actually use that same process to lay out the building, but instead of having two people operating it, we actually use a Robotic Total station, which is just a one-man system. Instead of a two-man system, we use a one-man system, because if you see in this, okay, yeah, you guys see my pointer. This right here, that's your total station. That is the actual robot. Now, you guys are probably like, Car, that doesn't look like a robot. It doesn't have arms or legs. It doesn't look like that Boston Dynamics robot dog that can walk around scanning things and open doors. Well, yeah, it's not a robot in that sense, but the reason why this is called a robot is because it could actually articulate itself, in terms of that head can actually rotate on its own and track this little piece right here. If you guys see my mouse, that is a radio prism. the whole head will actually rotate 360. And this middle section right here, that actually moves up and down. Oop, that actually moves up and down. And all that combines to track this prism. And how that helps bring BIM to the field is because those operators have this small little tablet right there. And with that tablet, especially having internet access, I could actually, from the comfort of my office, upload data from my model into the cloud. They could download it onto their tablet right in the field as long as they have an internet connection. And then they could actually select points. Before you guys saw my model, it actually has all these different shapes and corners to it, and these intersecting polygonal lines and all that. We could assign points to that, or the operator out in the field could actually bring up our model and pull their own or set their own points. Now, what does that do? Great, they have this on their tablet. Once they set that point, one thing I skipped was this robot. There's a process to locate it on the site. Once it knows where it is on site, this guy right here by himself can pick a point in the building, and this robot will know where it's at in the field and in the model and say, hey, walk 10 feet east and 2 feet north, plant down your rod, this point right there, and that's where your point is going to be for a column corner. I wish I would have explained that better. I guess just to kind of summarize, what it allows us to do is not only layout, but verify layout based off of points in a model, okay? So we are actually putting information from the model into these guys' hands for them to use this robot to tell them, hey, go to this location if you're trying to find this point, or this column or foundation or whatever you want in the building. So this actually allows us to be very accurate. Not only does it have GPS, but it actually uses radio and Bluetooth signals to exactly triangulate where it is. Just to give you an example, if set up properly, okay, everyone's familiar with the Hard Rock Stadium. I could locate a single pinpoint location within 1/256, 1/64 of an inch in that whole site. So what does that mean? You guys know the size of that stadium. It's like finding a needle in a haystack. I could locate exactly where that needle is in that haystack.
Well, you can pinpoint every single seat in the stadium easily.
Good point. To kind of expound on that, the screws that are in the seat, I could locate every single screw in that seat.
There you go.
And that's in relation to the entire building. So that's a robotic total station. Next is what Sakshi and Matt were talking about, AR. This is a software called Trimble Connect AR. Before I had mentioned Trimble, they have hardware and software for us to use. We use the software side. This is actually a picture of augmented reality that one of my associates is using. She's using her phone to overlay our model onto that same site that I was just talking about, the apartment complex in Coral Springs at the Coral Square Mall. Using QR codes located at certain points and synced with our model. You just take the phone, you scan that QR code, and knows exactly where it's at. And depending on what phone or iPad that you're using, it can actually use LiDAR system to scan its surroundings, and it can actually orient the model on your phone to the image on your phone. So we could actually give the owner and architect a good representation of, hey, here is what it's going to look like, your model right here in the field against the actual building itself. Not only is this useful for the architect and owner to know, like, hey, here's some issues that we had, or this is how it's going to look after we build it via the model, but we could also put this in the subcontractor or trades' hands as well. So, if they're installing the AC or plumbing system, they could actually overlay it. Now, while this technology won't let you be pinpoint accurate like the robotic total station can, it'll at least give you a general sense of, oh, there should be a window or an AC duct in this location. So, you know, it aids in them being able to install correctly out in the field as well. Again, pictures worth 1,000 words. I know I'm explaining it. I wish I had a video of this to show you guys, because then you can see how we use it. But, you know, we're putting a picture into their hands so that they know how to go out there and build what we coordinated. And that is from the Navisworks model that I showed you guys earlier. The next piece of hardware is drone technology. With drones, it actually allows us to go out and photo document the building. At least with how current builders is using it. We're using a company called SiteAware, and what they do is they actually go out with a drone and they will take a picture of the entire building, especially with who's building what. And then they will actually take my model and overlay it against the picture to see, hey, is what is installed out in the field actually what we coordinated? And if it's not, then they flag it and say, hey guys, Mr. Plumber installed a drain in the wrong location, or, you know, it's, you know, maybe 2 or 3 inches away from where you had it in your model. So then given that, it allows us to have actually a quality control aspect to it, to where now we can go back to the people out in the field and say, hey, you know, we overlaid what you built against our model, and we noticed that this was shifted 5 inches out of place. Now you guys are thinking, hey, 5 inches, big deal. It's, you know, the size of my mouse. Well, it can be a big deal, because see that toilet right there? If it shifts 5 inches to the left or right, you're not going to be able to meet building code or accessibility requirements. Like there's very certain clearance dimensions that you need to uphold. And if that drain moves too far to one side or the other, that's where, I mean, to some degree, we could use offsets to try to get it back into place. But, you know, after a certain point, you just can't. And then you won't be able to meet those minimum clearances. So here's an example of, you know, this wouldn't have been found until after the whole bathroom has been built, meaning, you know, it's air conditioned essentially, drywall's up, probably everything's installed, and it's short of painting. An inspector comes through and says, hey, you have this toilet that is, you know, you don't meet your minimum clearance requirements. I need you to tear it out and reinstall it so that, you know, an accessible person can come in. I guess a handicapped person can come in and use this toilet. And that's only for this one. What if this happened 300 times and it cost, you know, $1,000 to fix it? That's a lot of money. What is that, $300,000? $300,000 to make all these fixes? Well, guess what? With BIM technology, we were able to forecast this and, you know, correct it before, you know, it turned into something bigger. And that actually brings me to, I guess I need to wrap up right now. But so the BIM process, there's kind of 2 ways of seeing it. There's an office side and there's a field side. And kind of the fun of it is figuring out the whole process of, one, finding the problems in the office. And the other part is, hey, how do I get all these items that I found and fixed? How do I get it out into the field so that we can actually build it correctly? So, and it allows me to play with a lot of toys too, you know, not only with, you know, different computer software programs, but also, as you see, you know, drones or robots. So I guess with that, does anyone have any questions?
Let's open it up for any of the students if you have questions first. Because if not, I've got a couple of questions.
Okay, I see Sakshi asks, out of curiosity, how common is the practice of using drones for quality control in this manner? Okay, so one of the difficulties with drones is, one, in this aspect, you have to be licensed for just to operate the drone. There's a bunch of insurance things about it, but then there's also rules and regulations. And then the other difficulty part is depending on the location of your project with any type of quote unquote airport. Unfortunately, the definition of an airport is really loose. So like a helipad to a hospital is considered an airport. So if you're within 4 miles, you can't fly above a certain altitude, which can limit how much of the of your project you could photo document. Now, how common is the practice? You know what? I'm not necessarily sure about other companies. At least with ours, we're chomping at the bit to use it besides aerial photography to actually find a way to overlay it again using site aware to compare it against the 3D model. So, if other companies are willing to pay for it and use it, that'd be the only barrier of entry. Well, besides the fact that you have to have a BIM model or process set up in order to leverage that kind of technology as well. I mean, to some degree, you could easily just take the CAD files from the design team and compare it against that. But at the same time, what's the level of coordination and everything else that's been done to the CAD, and how accurate is it to compare against these photo documents from the drone?
I asked that question because you're the first person who's shown this using drone in this manner. I've never seen anyone use drone in this manner before. So I was curious, like how many construction companies are doing this? Like currently, is this a common practice? Maybe I'm just not working with those kind of construction companies.
Yeah.
Drones, I'm not necessarily sure. Go ahead.
Yeah, no, I'll just jump in and I'll tell you right now, Sakshi, and credit probably to CAR and the commitments from Current Builders, but I would say that Current Builders is probably is ahead of the curve, with the construction industry and other companies that are considered peers or somewhat peers to them with their use of technology and building information modeling. I mean, my company, we have a BIM and VDC department, but we don't do nearly what CAR just demonstrated that they're doing at Current Builders. I mean, I'm very impressed with the way they're using the technology.
Yeah, we use Ortho Mosaic with the drones, and what that does, we fly the drones over our projects to see in comparison to, say, the drawings and how the building's laying out, how the decks are, but we don't go into that detail of the with the drone for say the penetrations that was shown on that deck. We do use a total station, and we do also 3D scanning, which is as building the existing installations.
Yeah, that was actually one software that Matt caught me on that I'm sorry, not software, hardware is 3D scanning. It's I would say that's probably a way more accurate way of documenting what's being built out in the field and comparing to the model. There are workflows for that. And I only say that they're more accurate than drones just because it's literally tagging millions of points and kind of creating a digital twin of what's being built out there. With a drone, there's certain accuracy levels to it, just because whenever you photo document something, your photogrammetry, you're prone to having some distortions because of the curvature and lens and stuff. So, we're kind of getting into a lot of detail, so I'm just going to kind of just leave it at that. But, there's other ways of comparing what's built out in the field to your model. And thank you, Matt, for bringing up the 3D scanning. I should have had that under hardware. Yeah,
we use that heavily. And also the, with the drones and the total stations.
Mm-hmm. So good question. Any others?
So CAR, yes, I've got a question. So I assume in your capacity or role at Current Builders, you're probably involved in the hiring process for new BIM individuals to your company, right?
Mm-hmm. Correct.
So can you share, are you willing to share what's the maybe starting salary or range for that starting salary for new hires? And assuming you're hiring new people right out of college, or are you looking for people with experience, and what that salary looks like?
It runs the gamut in terms of experience. It just really depends on where a certain construction company is at. Like I speak with my counterpart at Cast, in terms of, kind of the talent we're looking for. And, at least with where they're at, they're currently in the mindset of, hey, let me find somebody who's had 2 to 3 years of experience. At one point, when I was growing my department, I was in the belief like, hey, let me get somebody who's new and green, because I want them to grow within the company. So it just really depends on, where the company is at with their BIM program. I would say, it's still, you have a pretty good shot if you don't have much experience, especially coming out of school, getting into a BIM department, because, there's still a lot of companies out there who are trying to get, their BIM department up and running, and it doesn't have to be at a big company. I mean, Current Builders is right now a medium-sized firm, then you got like Jacobs, and Matt's, who's a large company. So it just depends, but you can be hired regardless if you're inexperienced, new and green, to having 2 to 3 years, to even you've been seasoned like me and been in the industry doing BIM for 12 to 13 years. Now the starting salary, after accounting for inflation, because I haven't hired a new hire in a long time, I would say probably the starting salary now is probably somewhere in maybe 60s or 70s. I know about 10 years ago, the starting was about probably 50, high 40s, low 50s. So probably I would say, if I would give you a range, 48 to 53 about 10 years ago. So now it's come up to probably about mid 60s, maybe low 70s, but
that's a good starting point.
Yeah, I just haven't hired somebody new from school in a while, but I can tell you, on the mid to upper range, you can look anywhere from probably maybe 120 to 160, 170, and then after that, you're getting into your point of career to where you're getting to like the C suites, where you're like the chief of something.
Sure. Okay. No, I like students to hear about not only the career opportunities, but obviously what, the kind of money they can make.
Mhm. And here's one thing to kind of think about is, building a building, well, to some degree, well, at least with what Current Builders does, it isn't rocket science. So, it's kind of like the same thing over and over again for the past, I mean, there's only a certain way you lay up block, but, with the emergence of technology and things rapidly changing, there's a good opportunity for, if you have a certain interest in computers or something, to find a way to adapt it to the construction industry. I mean, mine came from the love of, computers just starting out, and video games, and wanting to, build digital space to actually, building a digital space to actually be built in the real world. And, there's a whole other facet to technology and how it affects everything else, not only for how we build, but how we manage the information, the flow of information, managing certain aspects of a project, whether it's schedule or money, or the financials of it. I mean, BIM can start to bleed into every facet of the industry. So yeah, it's definitely a very, there's a lot of room for growth there. So don't think like, hey, I can only do what CAR does and I'm going to be doing this for the next 20 years. No, I'm starting to see that it expands into other departments in the construction company that I'm at. And I'm pretty sure Matt, Sakshi, and Jacob could attest to the same thing.
Yeah,
Yes.
I had a follow-up question based on, when you say you haven't hired anyone in a while, why is that? Like, I was just wondering, like, how much of the opportunities do students have? Like, it's a good salary, good starting salary, but what if we have 100 students graduating all really well in BIM? Are there enough job opportunities in the market for them, for all of them to get placed?
Oh yeah, there's definitely enough opportunities for them to get placed. Well, as at least for Current Builders, I mean, I just went through a growth in my company, so that's why I'm currently not hiring. But ask me about maybe 6 months ago, it'd probably have been a good shot for a student coming out of college to get hired. But I would say to maximize your chances of getting hired, you have to really research the schools that have a good focus in the construction industry. For instance, and this kind of rings true for any industry that you go to. Like, you don't want to go to a school that is really known for marketing or being or law, for construction, just because they don't specialize in that. But like, and I'm not trying to tout UF, but I can only use that because that's my experience. So UF has a really big construction program there. At one point, it was like top 10 or top 5. I don't know where it is now. It could still be there. But what was great was that they went out of their way and had this career fair where you had 100+ companies going there to look for people to hire. And at the time, BIM was new, but even though it was new, I felt like I was like in an NFL draft. I had like 3 companies vying for me. They were asking, "Hey, like, will you come down and interview?" So really, the chances of you getting hired are really high, but you have to be strategic about it. Research those schools. If you have an interest in building construction, if you want to be an architect, look for schools that have a really good architecture programs. Because guess what? Probably a lot of the firms around the United States are going to key in on that and say, "Hey, if I want a chance of hiring a great architect, let me go to this school who specializes in it." And that's the same thing for if you want to be a general contractor. Find a school that has a good construction management program, and that's going to maximize your chance of being able to get hired. And I know I am talking about different disciplines, but guess what? BIM spans between disciplines very easily. I mean, I could tell you there's some architecture firms that I'm working with. After seeing what I do, they're now starting to get into doing the whole 3D model and coordination at a time. So actually, I don't know if you want to speak about that, but BIM is not only for construction companies. It's for anything construction industry related.
Oh yeah,
We're coming up in
definitely.
the end of our time, so let's make this quick, all right?
I'll just say yes, he's right.
Yeah, and because I just wanted to mention one other quick thing, but Cara, any other comments, or are you good with what you wanted to share?
Yeah, I'm good with what I want to share. If anyone has any questions, please feel free to reach out to your mentor or whatnot. They'll know how to get a hold of me, and I'm more than willing to answer any questions offline.
Yeah, no, Cara, so I just wanted to say thank you very much to Ho. I mean, great presentation, great information. Jeff Randall, when he did his presentation about mechanical, electrical, plumbing, also talked about how BIM and design job opportunities are plentiful on the subcontractor trade side where he works in the electrical business. So there's definitely a lot of great opportunities. Thank you again, Car. I just want to take 1 minute here at the end, and I'm going to steal the screen share, Car.
Okay.
And this will be super quick. Let's see here. Why is it not working? Okay, 1 second. I'm getting there, guys. I promise. Okay. Okay, so I just want to remind everybody, our students, that the scholarship applications are due by end of March. So this was the 1-page flyer that we created explaining the scholarship application process. We have 4 scholarships that are available, 2 for $5,000 each, 1 for $2,500, and 1 for $1,250. Every student should already know about this information. It was distributed a few weeks ago through your teacher, so hopefully everybody's already aware of this. I just want to use this meeting as a reminder that those applications are due by March 31st. They are only for students. This flyer gives you all the information you need to apply and what the requirements are. Bruce Davis, who's on our executive board, spearheads the scholarship application process. His email address and phone number are here if you have any questions. Please, guys, for seniors, We want you to take advantage of this. We want to give out the scholarships. Don't let the scholarships go uncollected. With that, next week is our next in-person classroom meetings. Looking forward to the progress everybody's doing on their projects. And I hope you enjoyed tonight's class about building information modeling.
Yeah, guys, I just want to add on to Jacob's comment about, hey, like how important these scholarships are. Well, guys, this is free money, like no strings attached. Like if you win this is cash in your pocket that, well, the only string attached is, hey, you know, you have to be in good standing and be in an ACE related major. But guys,
Right.
it's a free $5,000 in your pocket. So
Yep. Nope. Agreed completely, guys. We want to give this money out. So with that, thank you again, Carr, and have a good night,
Okay.
everybody.
thank
Thank
you
you,
guys.
Carr.
Have a good one.
Bye.
All right.